The advent of high-performance computing systems has allowed us to qualitatively change the class of questions that we ask and the speed at which we can respond to these issues.
Our mission at Virginia Tech is to support the entire university. And we have unique strengths at Virginia Tech for both educating the next generation of students and scientists and also helping to solve some of the most important problems of our day, problems that will have huge societal impact. As an example, we have a strong institution at Virginia Tech, Biocomplexity Institute, to support rapidly growing use in life sciences, whether it be genomics or infectious diseases.
If you look at what's going on nowadays, everything from various engineerings to social sciences, biological sciences, just about everything now is impacted by research computing. At the Biocomplexity Institute, we look at modeling systems from molecular scale level all the way up to planetary systems and how all these things interact in a very complex way. Our high-performance computing system, Shadowfax, is primarily built on Dell hardware using Intel-based processors. So that gives us very high performance.
A particular problem that our lab has a lot of interest in has to do with spread of infectious diseases. We can actually simulate an entire flu season across the US in about 10 seconds.
Another key area of research computing at Virginia Tech is the Virginia Tech Transportation Institute.
We focus on transportation safety. Our goal is to save lives, time, and money of people on the roadways of America and around the world. Most of our data comes from instrumented vehicles. Video data, accelerometer, GPS, radar, that all rides upon infrastructure that we built with the Dell C-Series servers. The Intel processors that are in those have been very effective at doing the kind of workloads that we have. It's certainly been very important to us.
Our work would not be possible without the computational facilities at Virginia Tech. We are really at the cutting edge of modern plate tectonic theory. We're solving 18 million degrees of freedom to investigate the physics of these processes. So doing our high-performance computing allows us to actually rewrite some of the textbooks on plate tectonics.
One of our roles at Advanced Research Computing is going to be helping migrate people to Hadoop. We have two more targeted Dell compute engines, one of which is 16 nodes, each of which has 43 terabytes local disk, and then Intel Xeon 24-core 512 gig memory CPU. The Intel CPUs provide roughly 2.5 times the performance of our previous generation CPUs with 1.5 times the memory bandwidth. Intel's AVX2 instructions provide us to get almost 2 times the speed up on the same hardware. That allows you a whole new way to analyze some of the new data that's available.
Clearly, there is a strong sense of partnership between Virginia Tech, between Dell, and between Intel. We have moved to be able to serve a full spectrum of computational and data analytics needs.
The work that's done here really makes a difference to people's well-being.
It's great to be involved with researchers who are solving problems, really making a difference in the world.